All right. So, okay, let's just try question one. See how good your memory is. Okay. You can open your own document. You can open your own document to see. All right. Then you can also ask me to scroll up and down. Up to you, whichever is easier for you. Okay. Do you remember how to do or not?
Yeah.
Okay.
Miss can scroll down a bit, just like a bit.
Know how to do or not?
Yeah.
Okay.
Is it like the
Oh,
reaction
wait,
rate?
wait, 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 wait. You don't tell me first. You write down first. If
Huh?
you tell me and I tell you, then it's just I'm doing the question for you. You try, then I know whether you understand or not. Okay? Where are you now? Have you done the first question? This is the
This
same
like
as what
write
we did
down
last
what?
week. A and A1 and A2 done?
Wait.
Sorry, ZiHua, what did you say? Write down where?
Yeah.
Just write down on a piece of paper. You don't have to write down on the board. You write down on a piece of paper.
Okay.
Okay? Uh, it's the same question I taught you last week. Okay? Hmm? Turn off the rice cooker, okay? Turn off. Yeah, I turned it off already. Okay. ZiHua, okay?
Yeah,
All right. Have you done, are you starting to do B?
I doing AII.
Okay. Do you want me to scroll anywhere?
No, it's fine, miss. I open my own Acrobat. Yep.
Okay, good.
Is it moving right now?
No, no, no. We can only move tomorrow.
Right.
We cannot use the bathrooms yet. You have to wait for the cement to dry.
Okay. Yeah. I mean, I suggest right. You got all.
How the rate of T1 is higher than T2. At T3, the rate is 0. Okay, correct. Very good. Explain. Okay, so you have to be specific. You have to say the concentration of what? Concentration of what decreases with time? What are we using in this reaction?
Concentration.
Of
Wait,
what?
let me go check back. Manganese oxide.
No. Look again. Which one is a solution?
Aqueous hydrogen peroxide.
Yes. The concentration of aqueous hydrogen peroxide decreases with time. Okay, so which one is concentration? Look at your notes. The amount of particles per
Per dm cube.
no per unit volume.
Uh,
decreases
Yeah,
with
I was
time.
thinking of more per diem sugar.
I mean, technically correct lah, but this is like overall. The amount of particles per unit volume decreases with time. Okay, can? If you want to write, you can write less collision frequency also can. Get it?
Okay.
All right. Finely powdered. Okay. So you must have a graph that ends the same, but it's faster. So this is the powdered one. Correct. Okay, explain. Finely powdered has larger surface area. Okay, correct. Describe how you show that a catalyst is not used up. Okay, correct. Filter. This one's a 4-mark question, huh?
It said
Filter.
filter, wash, rinse, dry, and relay.
Yes. Okay. Filter.
Relay.
Wash the residue with what?
Water.
With distilled water.
Oh. Miss, what's the difference between distilled and water?
Distilled water is pure water. Because if you just use water, it still could be heavy one.
Can you die by drinking distilled water?
No, distilled water is pure water.
Miss, I can see the water you're drinking now is not pure water.
This is tea.
I knew it.
Okay. Filter. Wash the residue with distilled water. Dry with filter paper.
Miss, you need
Okay.
to be so specific, man.
Yes, because it's 4 marks.
Oh.
Weigh again. It must be how many? 0.1 gram.
Oh,
Yeah.
you even need to say what should the result be, ah?
You can either, yeah, of course. That's why it's a 4-mark question, my dear. 4 marks.
I a bit dumb, bro. He need little kids to help himself.
4 marks. Okay, ready?
Yeah.
Next. Okay. 96 over 24,000.
That was how I calculate also.
Mm, can you press calculator one more time?
Ah, wrong.
You press
Nine.
calculator one more time and see.
Wait, ah.
And you press one more time.
1 over 250, 0.04.
Are you sure? You press to the it to the from
0.004.
ah
You know why? Because my calculator put 4 times 10 to the power of -3.
okay, you know you can actually just put 4 times 10 to the power of negative
Can
3,
I?
right? Of course can, standard what? Why not?
My life has
Okay,
been
so
a lie.
because this one wrong, everything else wrong already, lor.
No, the number 3 still. Eh? Wait.
Right. So this one would be 0.002.
Eh? Ah,
No, 0.008.
0.008. Eh, but that question I get correct. Also, it's 0.008. What?
So only this one you did wrong lah.
Yeah,
Okay.
it's a miracle. Everything around me is
So
a miracle.
M V is 40. Okay, so this one you write below here. So times 2 times 1,000 divide 40. So your final answer is 0.2
Yeah,
mole
more
per
per diem.
decimeter. All right. Okay, not bad. Okay. Okay, this one homework. Some homework, ah.
Why?
Okay. Uh,
Saya tak mau homework.
okay. This one you do as homework.
Homework is bad for the brain.
Too bad. Okay, 2 do as homework. And then, okay, 3 do now. 3 you
Question
do
3.
until here. 3 you do until here. Then C, I will teach you how to do. Okay?
Oh,
Okay, you do A and B. Number 3, A and B. Then C, I will teach you how to do.
or A and B okay.
Just do A and B. C, I'll teach you how to do.
Energy.
Okay, so wait.
Particles
Particles.
move faster, which
No
means
need, no
they
need to
have,
write that. You just have to say particles have more kinetic energy.
yeah,
I
and
mean, you
then
write no minus mark, but no need to write particles
more
have more.
particle, oh yeah,
Okay,
kinetic energy,
all
and
right.
then more particle can achieve common collide with activation energy,
Okay, can.
so more frequent effective collisions.
Okay, correct.
These are all copy from my last week notes one.
Okay, never mind. This is how you're supposed to write. Higher rate of effective collision. Okay, good. All right. Reaction involves enzymes do not follow the above pattern. So just explain why the initial reaction, then okay. Explain why
As
initially the reaction
temperature
speed
in
increases. So
as
initially,
as temperature increases over the optimum temperature, the enzyme starts to denature and therefore cannot and therefore cannot form an enzyme substrate complex with the particle.
okay, okay, actually no need to write so much. Enzyme initial after optimum temperature. Okay, and then before optimum temperature,
This one full bio mode.
yeah, before optimum temperature, uh, kinetic energy of particles increase with time. Increase, which is okay, with temperature.
I thought like after optimum temperature also kinetic energy also keep on increasing. Just in the
Yeah, but then
optimum.
yeah, you're explaining why it doesn't work,
There's
ma.
no
It doesn't work
use.
because it's denatured. Get it?
It just doesn't use.
Yeah.
Okay.
All right, now. Okay. How does the speed vary with time?
How does the speed of this reaction vary with time? Increase then decrease or
No, decreases with time.
eh?
Everything also
Decrease with
decrease
time.
with time. Okay?
Yes, I thought it's the same one with the enzymes one.
No, 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 no. It's this one.
Which
It's
question
this
is
one.
this?
This one. There.
Oh, oh. In decreases.
Okay. Why does the speed of reaction vary with time? Why?
Wait,
You read carefully, okay?
why does the speed of reaction vary with time? Because as reaction progresses, reactant particle use up decrease in concentration and the reactant is C6H5Cl.
Okay, correct. The concentration of this decreases with time. Correct. Okay. Now this one, so the same as just now lah. Okay, this one, right, you're gonna learn in another chapter. Okay. So basically, the reason why they put it here is because a catalyst is used to increase the rate of reaction. All I want you to know for now is a catalyst is always transition elements. Okay, transition elements are catalysts.
Transition element is the one that group one.
Yeah, the one in the middle.
Oh.
Okay. So all I need you to do is for today's homework is, for now lah, do question 2 as homework. Okay. I just sent you a second document. Okay. All right. Can you look at question 3 of that second document?
Wait, where is your, okay. Wait, I opening. Okay, Leo. Do which question?
Question 3.
3. Is it the magnesium and excess of accident?
Yeah, correct.
Suggest a reason why magnesium, which is denser than water, floated. Magnesium, which is denser than water, floated to the surface. How to do a question with I?
Read first, you read first.
But
Okay,
just
why don't you try and I write the equation for you and then you think. Okay?
uh-huh.
All right. Acid and metal, what do you get?
Salt and salt and H2O.
No.
H2, yes.
Yes. Okay. Now think a little bit. I give you 2 minutes to think. Okay? All right. Volume of hydrogen is measured every 15 seconds. Okay? Hey, where did you go? The magnesium kept rising to the surface at one experiment. This was prevented by twisting magnesium around a piece of copper. In the second experiment, the magnesium was held down by a plastic net fastened to the beaker. Suggest why magnesium, which was denser than water, floated because...
Miss, I think I know why now.
Okay, what's the
Is
reason?
it because the bubble of
Hydrogen gas
it pushed
produced.
it up?
Yeah.
Because
Hydrogen
you say very
gas,
light now.
bubbles produce. Okay.
So,
Iron, zinc, and copper have similar densities. Why was copper a better choice? Okay, this one you might not know. Copper does not react with acid.
because the lower kind of
No,
low
yeah, it's
the
lower reactivity, yeah.
copper, silver, gold. The last one.
Okay, copper does not react with acid. The only difference in the two experiments was the method used to hold down the magnesium. The results are shown below. Okay, why do you think? Okay, think this one. I let you think.
Huh? Oh.
This one, question B. Okay, you try and do question B. B, C, and D. Okay, B, C, and D. Then I want to teach you another experiment. Are you done? Still doing? Okay. So copper acts as a
Catalyst.
correct. The experiment was repeated using, okay, this one, right? This one you will learn in another chapter. These kind of acids are known as weak acids. When they have weak acids, they have a lower concentration of hydrogen ion. They have a lower concentration of acid. So what
Yeah.
do you think the graph will be like?
If they have like less concentration of acid,
Yeah. So it'll be
probably
higher or lower?
lower, right?
Yeah. No, it will eventually be the same because the concentration is the same, but the concentration of acid is lower, so it'll be slower. Okay? Can?
Mm.
Because the acid is excess, ma. You look from the top, the acid is excess. Okay? How would the graph formula be the same? So the rate will be lower, so it's less steep. The curve is less steep. How would it be the same? Total volume of hydrogen is the same. Get it?
Yeah.
Okay, give two factors which will alter the rate of reaction.
Temperature increases,
Okay, temperature.
particles move faster, which
Okay.
has
So you just
which
have to say,
means they have
because it's
more
only 1 mark, you
kinetic
just have to say
energy.
you just have
More
to say particles have more kinetic energy.
more particles collide with activation energy, so more frequent and effective collision.
Can. Okay. Second one?
Particle size. Particles have higher collision frequency, so effective collision also increases.
Okay, so what you can say is use magnesium powder. Okay. All you need to say is larger surface area. Get it?
Okay.
Okay, you done?
Almost. Done.
Okay. All right. Now, we done so many experiments, right?
Yeah.
This is one last experiment I'm going to teach you. All of our experiments before this all collect volume of gas, right? Except for this. Okay, can you read this question first? Okay, read already?
Yeah.
Okay, so the equation for the reaction between sodium thiosulfate. Okay, so you see this one is aqueous, right? This one
Mm-hmm.
is aqueous. This one is aqueous. This one is solid. This one is gas. So if other reactions I'm able to collect gas, why not this one also I collect gas? I cannot collect sulfur dioxide gas is because sulfur dioxide gas is soluble in water. So I won't be able to collect any gas. Okay, I won't be able to collect any gas. Okay, so what
Uh-huh.
I do instead is This is colorless, this is colorless, this is colorless, this is colorless, this is colorless. Only sulfur has color. And the color of sulfur is a yellow solid. So what I do is I put a beaker and underneath the beaker, I put a piece of paper. And on the paper, I draw a cross X. Okay? All right.
Yeah.
Now, when I draw a cross X, when I add it, I put my eye and I look and I swirl the reaction, swirl the mixture. What happens is when when the yellow solid forms, eventually the yellow solid will completely cover the X. When the yellow solid completely covers the X, then I press my stopwatch. So that is the reaction time. Can you understand?
Yeah.
Okay. So my chemicals are sodium thiosulfate, okay, 50 centimeter cube, 0.2 mole per decimeter cube of sodium thiosulfate, okay, 5 centimeter cube of 2 mole per decimeter of hydrochloric acid. So you know the acid and you know the sodium thiosulfate. This is sodium thiosulfate, okay? So when these two add together, you get a yellow precipitate that covers the X. Can you understand?
Yeah.
All right. The experiment was repeated using 25 centimeter cube of sodium thiosulfate, okay, and 25 centimeter cube of water. And a further 2 experiments were given in the table. Okay, see, yeah? So the first experiment, how many things can I change in an experiment?
One.
Okay, so I'm already changing the volume of this, which is basically, I'm actually changing the concentration.
Yeah.
I'm adding more water, I'm diluting it. So I'm changing the concentration of the sodium thiosulfate. I can only change one thing at a time. I cannot change the second thing. So the acid has to be all the same, 5 centimeter cube. Okay. So
Mm-hmm.
what happens is the first one I add full sodium thiosulfate. The second one I add only 40 sodium thiosulfate and I dilute it with 10 centimeter cube of water. The second I put half. The third one, half. Sorry, the fourth one is 10/40. So the slowest one will be who? The last one, ah?
Okay.
Okay. Why must you keep the total volume the same? To ensure a fair test so that the depth of volume is constant. Okay.
Okay.
Can you understand?
Yep.
All right. How and why does the speed of reaction, how does it vary? Becomes faster or becomes slower? Look carefully from experiment 1 to 4. Faster or slower?
What?
Does the experiment become faster or slower?
Hmm.
Hmm.
Slower.
Yeah. Okay, why does it become slower?
Concentration decreases.
Okay, please write this answer. Okay, write this answer and write this answer. Okay, can? And then send
Okay.
to me. And then you can go and sleep. Quickly. Are you done? Can I discuss? Because I have another class.
Okay.
Okay. How and why does the speed reaction vary from 1 to 4? The rate decrease. You just write the word rate. What happens?
As concentration decreases, rate of reaction decreases.
Rate decreases. Concentration decreases. Concentration of sodium thiosulfate. Must always mention who.
Okay.
Decreases. Okay, so less particles
Collide with
per
each
unit volume, and then you can talk about collision frequency, all that. Okay. This one?
As concentration decreases, there are less particles, so less collision and less frequency of effective collision.
Uncle. They are only talking about temperature, uncle. Everything is the same.
Particles
Oh, my dear
have more
uncle.
kinetic energy, so
Ah,
more
so this one
particles
is
can
talking about
achieve less
temperature.
time
Ah,
with activation energy, so more frequent effective collision.
correct. Okay. This one no need to. Okay, this one not homework. Only the other one is homework. This one
Okay.
you haven't learned yet. Okay. Next week we will do. Okay, so you cannot forget rate. Next week we're gonna do something called yield. Okay. So yield
Called
and
what?
rate. Yield. YIELD.
Oh, I thought that's like something you get from the reaction or something.
Something like that also. It's also connected to that. Okay, so next week we're gonna talk about yield. Okay, and then we're gonna use both yield and rate. Okay, do you remember you got homework?
Yeah.
Okay, let me send to you first. Okay, so only one question as homework, all right?
Okay.
Okay, so what do you need to do? Do the homework, study. Next week we're gonna do the next
You.
subtopic. Okay, Ken, and you must remember this subtopic because the two subtopics are related to each other. Okay?
Okay.
Okay, bye-bye.